All right, sixth graders, flex those hand muscles. We're going to write a lot today. First, I want you to recall that equivalent expressions are expressions with the same value. In other words, they're equal to, right? You see equivalent, equal to. So we can use certain properties to write equivalent expressions. So first we have the commutative, C-O-M-M-U-T-A-T-I-V-E, commutative property. So we have the commutative property of addition. So our number example would be 17 plus 2 equals 2 plus 17. It doesn't matter where they move to, right? Our algebraic example would be A plus B is equal to B plus A. Doesn't matter which way they're moving, right? They're commute. So the order does not affect the sum. Okay? Then we have the commutative property. You guys remember these? Of multiplication. So our number example would be 5 times 4 equals 4 times 5. Our algebraic example would be A times B, or AB, right, equals B times A. So the order does not affect the product. So you might be asked to use the commutative property to write an equivalent expression. So if we had 18 plus 60, you would write, flip them, right? 60 plus 18. Not too shabby, right? If you had 15a plus 7b, you would write, flip them, right? Flipping them. 7b plus 15a. Not hard, hopefully. And with the multiplication, you might have 12 times 7. So you would have to write, flip them, 7 times 12. And, oh, that was number 3, silly me. And this would be 4. So if you had 4x times 9, you could also say that it is 9 times 4x. Not bad, right? Not bad at all, hopefully. Now, associative. Associative. Oh, I gotta write faster. Okay, so remember we have the associative property of addition. So grouping doesn't affect the sum here. So our number would be 9 plus 1 plus 6. Doesn't matter what order you do it in. And same here, A plus B plus C, or A plus B plus C, right? Remember these? So the associative property of multiplication doesn't matter who you associate with, right? Actually, it does. Be sure you're associating with people that build you up, right? So grouping of factors doesn't affect the product. Remember, these are just with addition and multiplication. So our numbers would be 8 times 7 times 2 is the same as 8 times 7 times 2, right? Algebraically, that means that A times B times C is the same as A times B times C. So, if we asked you to use the associative property to write an equivalent expression for 16 plus 9 plus 24, you would write, you'd group them differently, right? You'd leave 16 out, and you'd group the 9 and the 24. So algebraically, 2x plus 1 plus 4x. This time you might leave out the 4x and then group the 2x and the 1. Okay? So with multiplication wise, 7 times 16 times 5, you might include that 7 this time in that group. He was feeling left out. And then algebraically, 1/3 P times Q. Or you could leave the 1/3 out, and P and Q could be best friends now. Man, it doesn't feel good to be left out. Gosh. Alright, finally, we have the distributive property, which we just went over. So I want you to remember distributive property. Just remember A times B plus C is equal to A times B plus A times C. And A times B minus C equals A times B minus A times C. So you might use the distributive property to write equivalent expressions, which you are very good at going back and forth to. Remember, when you're factoring, so if you already have a simplified form like 6y minus 30, you're going to have to factor. Factoring is part of it. Factoring is part of this distributive property, so you have to take the 6 out, then you can take 6 out of here, which leaves you with 5. Okay? Or it might ask you to go the other way, right? It might say 9 and multiply through. So either way, you're using the distributive property to make an equivalent expression. So 9 times 3 is 27, okay? 9 times 1 is 9. All right? So that was a quick distributive property, but we've just been going through this. I wanted to get to the identity property. So the addition says the sum of 0 and a number is the number. So if you add 0 to anything, you get whatever that number was, right? So a plus 0 is always going to be a. Now, for multiplication, the product of 1, writing 1, and a number is the number. So a times 1 equals a, right? For identity. The multiplication property of 0, you guys know all these. Multiplication, you just don't know, you know it. Property of 0. Remember, anything multiplied by 0 is what? Is 0. Okay, are you ready for this? Inverse property. This one might be a little bit new. The sum of a number and its opposite is 0. So 5 plus the opposite of 5 equals 0. It's really just 5 minus 5, right guys? So a minus the opposite of a, a plus the opposite of a equals 0. Whew, losing my mind. Alright, finally, I know you guys have hung out with me long enough today. The product of a number and its reciprocal, remember when you flip it over? Reciprocal, I'm losing it for real, is 1. So the product, sorry, my chicken scratch here. The product of a number and its reciprocal is 1. So 3/4 times its reciprocal, when we flip them, we have 4/3. That gives us 12 over 12, right? Which is just 1. In other words, a over b times b over a equals a b over b a. And we just said these are the same thing, so they are 1. The product of a number and its reciprocal is 1. Alright guys, thanks for hanging out with me this long. You did it. You made it to the end.